So our next talk is from Clemens Meyer. Clemens Meyer is the host of the YouTube channel Element 14 Presents, and he's the founder of Mayor Makes EU and initiator of Smander.com, who makes product compliance like online shopping. So he is going to talk to us today about CE for makers, so how to take Kicad and leverage the power of CE documents and what that can do for your product. So please give a warm welcome to Clemens.
Hello, welcome to my talk, and maybe one or two or many of you have thought about making their own products a reality. So you take your project from being nothing more than a project to actually a product that you can sell. Well, there are a lot of hurdles with it, as you know, not just manufacturing, but also there's a thing called certification. There are laws and rules you have to obey, and the topic is very daunting to most people. It also was to me. So about 3 years ago, I started my journey in compliance, and turns out I hate reading stories and I love reading law texts. And it might be pathological, but that won't keep me from doing this. So, CE is much more than EMC. EMC, electromagnetic compatibility, most people have heard about that, and the common myth that I get a lot is, yeah, you basically send your board to some test lab and they do some tests, and then if you pass, you can sell that. But CE is in all actuality much, much more. It's a much bigger topic, and it's not a single thing, it's a process. So the EMC compliance stuff that we all know, that's just one little piece of a whole process. We have multiple things to care about. We have external and internal documents. The external ones are those that you get to see when you buy a product. They are the declaration of conformity and the user manual. In the user manual, you also have some safety warnings in there. So everything that is safety related, you have to be informed as a customer. And the declaration of conformity is the declaration of the manufacturer that this product complies with all applicable laws and regulations. So it's guaranteed to be safe, because law number one that is above all these CE specific topics is the General Product Safety Directive. In Germany, they have a special law for that, the Allgemeines Produktsicherheitsgesetz, really nice short name. And that basically says, in a nutshell, you are only allowed to sell safe products. If a product is not safe, you can't sell it. And there are internal documents, that's the stuff that the only people who get to see that usually is you as the manufacturer and the authorities if they ask for it. So if you sell a product and the authorities ask for the internal documentation regarding CE, you have to give them these. Or at least show them, so they can get to you and you show them all of these documents. The risk analysis, technical documentation, assessment, and a lot others. These all depend specifically on your product. So if you ask a general question, you will always get the answer, it depends. And that's because you can't give an easy answer to a question that can't be phrased simple. So it's all dependent on specifics of your product, and very small details can have great effect. And we are talking now about the technical documentation, because that is the one that you can do completely on your own with Kicad. And I use Kicad for basically everything in my company, from designing PCBs to actually doing all this compliance stuff, because open source has some very big advantages. If you're manufacturing an open source project, that means most of your technical documentation requirements are already fulfilled. Because when you publish a project on the web, you usually do it in form of a repo. We have all your Kicad files, you have your step files for the mechanical parts, you have maybe the calculations that got into it, how it actually works. You have some documentation about the inner workings of the product. You have documentation about how it's for usage. These are basically the biggest chunk of your technical documentation. So if you can build it with the files that you provide, that is usually a very good starting point. Depending on the product category, you need to do a bit more or have it in a specific form. But in general, if you have your full source, that is already a very good point. So you have to put this all in a compliant form. Compliant form means the authorities have to be able to assess this, if it's correct and if it's in a state that is actually compliant with the regulations. So usually you just make PDFs, but also Kicad files are applicable to this because it is open. That means everybody can get the software, everybody can look at it in detail, they can zoom in, they can isolate specific nets to look at those closer. So Kicad is actually a very good viewer of source files in case somebody has to inspect them. That's also how I use them. So if you send me Kicad files, that's my preferred format because I can just look at every single aspect of those instead of zooming in a cruddy PNG file. Also, you have quality control documentation that you have to do, and you can also do this with Kicad. But I have to abuse it a little bit, and I'm very happy that you can't revoke my license to use Kicad regarding what you're about to see, because haha, it's open source. You can't force me to be normal. So normal Kicad projects, I do that as well. This is this board on the side is basically my latest Element 14 Presents project, which is not out yet. Don't show anybody. And the other one is a little board that I did a few weeks ago, and you may see what I did wrong there. Spoiler, the diode is in the wrong direction. So these are normal Kicad projects. Normal Kicad projects are very good to derive your source file. Grouped HTML BOM, very good for documentation, by the way. So this is the weird way I use Kicad. You not only have devices that are just a PCB in a case, you very often, and especially if you're in the space with machinery, experimental stuff, scientific stuff, you often have machines which have an electrical cabinet, and then you have devices mounted inside that electrical cabinet, and you have to document how they are wired up. They have to be tested in the way they are mounted in there. And for the quality control, which is part of the whole CE process, you have to document how they are built so they can be reliably built the same way, the same compliant way over and over again. So you have to make sure that there are steps documented how these things are actually built. This is pretty much just eSchema, brutally abused by just drawing some boxes and putting some connectors on there to schematically show the components that are mounted into an electrical cabinet. We have a microcontroller, we have a BLDC controller, the pump, then we have some PSUs. A sensor is just normal stuff. We mark them as what they actually do. So this is basically the view of an electrical cabinet from the electrical connections perspective. And usually we draw a schema in Kicad, and then we have the other view, the PCB view. So we see it in how it's physically connected as opposed to just electrically. So now it gets ugly. This is a drawing of the machine cabinet in PCB-New, and you can see the different components on there mounted on DIN rails, and the positions of the connectors are now where they are physically. The parts themselves are in size relation to where they are physically, and all the wires that are represented by traces here are where they would be physically. So you can now derive from these a bit of information. And that is, you can tell where multiple lines are connected, so they branch off. You can tell which lines are allowed to cross, which are not allowed to cross. You can see which ones are thicker in gauge than others. The 3D viewer is pretty useless at the moment, but if you use Freecad, hooray for open source, you can just make basically representations in 3D of your components, exchange those models for the connector models that you put in there, and then you basically have a 3D layout of how this cabinet would look before wiring it up. It would be pretty cool if you could render traces as objects. Maybe that's a use for a plugin, so we can actually have like a physical representation in 3D, also how it should look wired up. And now for the actual use in the documentation, we have to document how the stuff is built up. So of course you can't produce a PCB with these files, but what you can do is basically you isolate each layer. As you've seen, I have put each type of cable on a different layer. Also, I've split on ground connections and power connections. So I can just turn on a specific layer, add to the sheet some text about which kind of wire it is. This could also be automated. And then I make basically PDFs with the different, steps by highlighting each of these layers. And basically KiCad turns now into pretty much an interactive thing where you can scroll through your steps of assembly. I can now just make PDFs of those, print them out, or just add them to my documentation. And I've done in KiCad what usually you would do in a graphics program. The nice thing is, because we have now connected these views with a schematic view, that means while drawing, we can't make any connection errors because they are dictated by the schematic. So that's a bonus compared to a graphics program. And also, if we now get really dumb, because these boxes here, those now represent just monolithic devices, basically. But what if some of these devices are made by you, and you would make a big machine that consists of devices that you made, and they are now interconnected in an electrical cabinet. Well, we before learned that KiCad doesn't support putting multiple devices and multiple projects into one project file or into one schematic. Well, if you get creative, you can get kinda there. You can make a hierarchical sheet. Instead of these boxes, you basically link to another sheet. In that sheet, you copy in your schematics from the specific project. So basically you make a big project, copy in all the schematics files from the other project, and now you have basically a navigatable electrical view of your machine where you can navigate from the highest point, the stuff that people can see when they open the cabinet and follow the lines, down to the component level. So you actually have more than one device in one project. You can't make a PCB out of that, but you have all the stuff for your documentation in one place in a KiCad project file. And that is easier to navigate than other things. So this is basically how we use KiCad now. So for inspection files, for production, of course, ourselves, and for the documentation to generate these things, but we have a bit more planned. One thing that we do, we have basically our own compliance assessment suite program, which is just a bunch of shoddy Python code with a textual TUI, so not a GUI, it's a text interface, but it looks like a GUI. And I would like to make that basically, so it has a compliant format that is based on the CERN open knowledge standard, which is just a YAML file. And that basically packages up all your source files into one big zip file. And that zip file conveniently is named .std, because it's something that you give to other people. And the file including all the certification is called .std. You can guess that reference yourself. So now these files can be interchanged. We want to basically make that interchange happen with as many programs as possible, including KiCad. So maybe I'll make a plugin or something. But it's already compatible, or mostly compatible, with inventory. So you can manage your projects there, import them here and there, make your certification add-ons without breaking the format. And for the long way down, if we can make this plugin stuff really work, I would like to basically have a way to start my project in KiCad, and at the end, when it's finished, I click certify, and then all the stuff gets packaged up automatically, sent to Smander, we do the assessment, you get the data back, and have it all managed in one place inside your KiCad repo, basically. So, if there are any questions, you can get all the stuff that we do at smander.com. c@smander is my email address. I'm the guy in the blue t-shirts on most events, and I'm here all the time. So if there are any questions, I would like to take them, and you can meet me outside anyway. So thank you very much for your attention, and I've been shorter than I expected.
Thanks for the presentation. Since you were so fast, I maybe missed it. Did you consider like a plugin or something in KiCad where you you take the designer through the whole thing and.
You mean where you basically integrate the certification aspects directly into your design?
Something like, it could be a checkbox. It could be having documents in there. It could be taking information out of the schematic and layout. Or I don't know. Something
I'll do
like
a
that.
live demo. I just need to figure out how to get that on the screen. Basically, yes. I'm basically working on a software suite which gets a user version that is meant to be. I'm just trying to start that thing. It's basically meant to. So you have it on your computer. You integrate it into your KiCad. You add your data to it. Click send. I have the big version basically where I can do all the backend stuff. Add to it, you get it back. So instead of reading PDFs and stuff, as it is now, you can then basically automatically import all the certification-related stuff, including like highlighting inside the schematic where there are problematic parts or some layout issues and stuff. So the end result should be basically a thing that helps you do this all on the fly during your development or afterwards. So I'm trying to start a thing. Okay,
So while we're waiting, do we have any other questions? Yeah.
Oh, okay, it boots. Okay, now I have to figure out how we switch screens. Okay, any other questions?
Yeah, I have one question. Because for CE marking, there are different standards that can apply. And part of the CE certification is actually knowing what part applies to our project. So,
yes. Exactly. That's basically what we do. So the hardest part, or the first step of CE certification, is pretty much knowing what applies to your project. So to be clear, you can do everything regarding CE yourself. Yeah, there's nothing in the law forbidding it to do. Is that a good idea? Maybe, maybe not. I thought it was a good idea, then I got into the rabbit hole, now we're here. The thing is, most people don't find pleasure in that. Most find it daunting, grueling, or they just don't want to do it, and they rather build awesome stuff. The first step that you usually take is go to somebody who knows the stuff, show them your product, show them what it does, and then get an assessment. That is basically analyzing the product to know which rules actually apply and if there are any problems with it that you need to circumvent before you go any further. So that is one of the services that we offer. If you look at this is the basically the technical documentation client, version not ready yet, but you can basically load in your file, put in all your data in there. It gets stored in a YAML file. As you see, you have a lot of options for stuff that you can enter. And here under certification, basically, that's now like dummy data and stuff. You would then have all the related stuff that got out in basically an easy to read format where everything is in there. And we're working on that for like half a year now. But in the end, you basically should have a little program that you can also integrate into your Kicad stuff, manage all these findings in there, and have everything that is related to your project actually where the project files are. So there's basically your Kicad files and a YAML, and you basically open it with this program or plugin, and everything is in one place. Yeah. So you enter what you have, we enter what we find, and then basically you add some more documentation like the user manual, test results, etc. And then you basically have all the documents ready that you need for certification. Yeah. Do we have another one?
Okay, thank you.
Okay.
Thank you, Clemens.